Assalamu alaikum. Bismillahirrahmanirrahim. Today in this video I am going to solve the following Olympiad problem that is provided above. So I am reading it out. The equations x square plus ax plus b equals 0 and x square plus bx plus a equals 0 both have real roots. It is known that the sum of the squares of the roots of the first equation is equals to the sum of squares of the roots of the second one, and a is not equals b. Then a plus b equals 0 minus 2, 4 minus 4 impossible to determine. So this question I suggest that maybe you could pause the video, proceed with the solution, and then watch my own solution to the question. Obviously, to these Olympiad problems, there is not only one solution. There are many solutions in our in which we can answer this question. So now we are assuming that alpha 1 and beta 1 are the roots of the first equation. And alpha 2 and beta 2 are the roots of the second equation. So now it is known that the sum of the squares of the roots of the first equation is equals to the sum of the squares of the roots of the second equation. So now alpha 1 square plus beta 1 square, that should be equals to alpha 1 plus beta 1 whole square minus 2 alpha 1 beta 1. Alpha 1 plus beta 1 should be equals to the coefficient of the negative coefficient of x of the first equation. So that should be equals to minus a, and the product of the roots of the first equation should be equals to the constant of the first equation. So we are having minus 2b. So we are going to obtain a square minus 2b. Taking on the next page, in order to simplify this, I am going to write it over here, a square minus 2b. So now on the next page, I am going to write alpha 2 whole square plus beta 2 square, that is equals to alpha 2 plus beta 2 whole square minus 2 alpha 2 beta 2. So alpha 2 beta 2 plus beta 2 should be equals to the negative coefficient of x of the second equation. So that is equals to minus b whole square, and the product of the roots of the second equation should be equals to the constant of this next equation. So I am going to write 2a over here. So we are going to obtain b square minus 2a. Now I am going to write the sum of the sum of the squares of the both roots all together on this page, whole square, that is equals to minus b square minus 2a. Since they are equal, it is known that the sum of the squares of the roots of the first equation is equal to the sum of the squares of the roots of the second one. So we are going to obtain a square minus 2b equals b square minus 2a. Now we are going to obtain to complete the algebraic technique required in this question. A minus b, a plus b, that should be equals to minus 2a minus b. Now if we move it to the next side, we are going to obtain a minus b multiplied by a plus b plus 2 a minus b, that should be a minus b equals 0. So now we are going to obtain a minus b as a common term, and a plus b plus 2, that should be equals to 0. So either a is equals to b or a plus b is equals to minus 2. Now since in this question it is written that a is not equals to b, so this solution is rejected. And we have this solution, and since they are asking for the value of a plus b, it's going to be equals to minus 2. So we are going to take mark this option. Hope you enjoyed the Olympiad problem solved in this video. Inshallah, in the next of the videos, I am going to come up with more Olympiad problems in order to add to the interest of the listeners, and in order to make people appreciate that how these theories could be used to solve the range of complex problems. Thank you very much.